Hello calculus students, this video is for 4.6 part 3 is curve sketching. So let's review what's a graphing or graph sketching strategy. So we should find intercept, we should find asymptotes by looking at end behavior. We should find vertical asymptote. And then the most important thing is to find local max and min by running the first derivative test and inflection point on concavities by running the concavity test. Okay, so we did example 1, so this is example 2. So the function is x squared plus 4 over x squared minus 4 is a rational function. So first of all, we would say, is there any x-intercept, y-intercept? X-intercept is when y equal to 0, so there's no x-intercept because you cannot have x squared plus 4 equal to 0. So no x-intercept, so it does not cross the x-axis, you can say. Because when you solve it equal to 0, there's no solution. What about y-intercept? You plug in 0, so that would be 4 over negative 4, so y-intercept is negative 1, right? Y-intercept is y equal to negative 1, so it's 0 comma negative 1. We have 1 point. And then what's the next things? Domains you cannot have divide by 0, so domain is no x squared minus 4 cannot be 0. Cannot be 0, that means x cannot be 2 and negative 2, because when you do square root it's 2 and negative 2. So these two are actually vertical asymptote. Vertical asymptote is x equal to 2 and x equal to negative 2, because you cannot have negative 2, because you cannot have it cancel. There's no hole in this particular graph. And so what is about end behavior? So end behavior is horizontal asymptote. Horizontal asymptote, we would just do the limit. The degree is the same, and they have coefficient of 1 and 1, so y equal to 1x squared over 1x squared is 1. So it's the horizontal asymptote. So you look at the strategy. So we have covered all these. So the rest is first derivative and second derivative. No, not second derivative. Concavity test. So we don't have enough space here to do f prime and critical value. So I'm going to switch to a notepad over here. So then we can write the result back. So how do I do? So first of all, we would say we need to find a critical point. So do first derivative. Still remember quotient rule, x squared minus 4 square. This is f and g, right? F and g. So f prime, so f is x squared plus 4. G is, so that's why it's not enough space. X squared minus 4. F prime is 2x. G prime is also 2x. So we would fix first, right? 2x over x squared minus times x minus 4 minus GIF 2x and x squared plus 4. So the derivative would be 2x cubed minus 8x minus 2x cubed minus 8x over g squared, which is the original denominator, x squared minus 4 squared. So the x cubed cancels, so it would be negative 16x over x squared minus 4 square. So if I am to set this to 0, so you need to do this, and then to find a critical point, you would have 0 equal to negative 16x over x squared minus 4 square. Okay. So the bottom is a square, so it would not make any difference for solving it. So the only critical point is x equal to 0. What about undefined? Undefined at, so they are not in the domain, but they're undefined. Undefined at x equal to 2 and negative 2. So you might ask, Ms. Chen, they are not in the domain. Why would I need to care about them? They are still critical point because they are undefined in the original function. But the most important thing is they undefined in the derivative function. So if they undefined in the derivative function, they might change sign. So we would need to put them. Yeah, how do I change it back? So I'm going to do the first derivative test. So we have three numbers. -2, 2, 0, 2, and I'm to check f prime. So if I put it, this is f prime, right? So negative 16x over x squared minus 4. Well, no matter what you plug in, the bottom is a square, so it's not going to, this is all going to be positive. So if it is negative number, negative 16, a negative is always a positive. As a matter of fact, this would still be positive because anytime you use a negative number, you have negative 16 times it. But this would be a negative because you have the negative. So it's really easy to test. So this is increasing, but this is decreasing. So the only local max is, there's no local mean. Local max is x equal to 0. And when x is equal to 0, going back to the original function, we have it, I think, like this. If it is 0, so it's -1. And that is a local max, no local mean, and then it's like all going up. Maybe I'll do it on this side. So what about f double prime? We can do concavity test. Look at if there is point of inflection. Okay, f double prime would be the derivative of this. That is kind of difficult. So this is my f and g. So use another color, distinguish it. And this is g, so we would say this new f is negative 16x. G is x squared minus 4 square. So f prime is negative 16. G prime is chain root 2 of x squared minus 4 and then a 2x. So that is 4x x squared minus 4. Okay, so f double prime would be, let's do shift and stuff. In the worksheet, I actually give you the x squared minus 4 to the 4th power, and then fig will be negative 16 x squared minus 4 square minus gif is 4x x squared minus 4 times negative 16x. Then all of them has an x squared minus 4, so I'll simplify it. So it turns out that it will be negative 16 x squared minus 4 minus 4x x squared. Okay, the x squared minus 4 cancel, so we will say negative 16x all over x squared minus 4 cubed. And then it would be, all it would be, I'll factor the 16 out, so I have negative x squared plus 4. This would be 4x and negative 4, so plus 64x squared. Okay, no, plus 4x squared, right? And then plus 4, yes. I have it written down somewhere. X squared minus 4 cubed. So this would be 16. And then 3x squared plus 4 over x squared minus 4 3 times, power 3. And then in worksheets that you need to do, I usually give you this because it just takes too long to do. So we have this. Now we are going to do the concavity test. So what is the undefined number? Undefined is -2 and 2. This tops is no solution. If it is equal to 0, is no solution because it's always positive, right? So that's all I have. I would just need to do testing. So if I do, so this is all positive. So if I do a number that's larger than the absolute value is larger than -2, it would give me positive, right? These are positive for f double prime. So concave up. And if I have a number 0, so you can see the -4 cubed is negative. And this is positive. So concave up on this, concave down, there's 2 inflection. Are they inflection point? Well, they're not in the domain, so no inflection point. Although there's change of concavity, but -2 and 2 are not in the domain, not in f of x. So no inflection point. We just know that it is concave up from a pass of -2 and then concave down on the other side. So if this is the case, then we can actually graph it now. Using all the information that we have, let's do a small graph here. So we have a 0, 1, which is a local max. And we know that it is concave down here, so we know it will be that way. -2, 2. And then on this side, it's concave up. And then there is a asymptote of what? 1, right? So the asymptote of 1. So that means it's going up this way. And then this is a concave up, so it cannot be down. So it will be going this way. Okay, so you can do some point. Oh, it's not very good here. So this is the graph. Okay, point of 0, 1, one local max, no inflection point, 2 vertical asymptote, and 1 horizontal asymptote of y equal to 1. Right, so that's our graph. Let's write it down in here. We can say our f double prime, just record it to recall what we just did. We say our f prime is equal to -16 x squared minus 4 square. So enough space. So we would have a -2, 0, and 2. And in terms of increasing, is always increasing, right? And then it's always what is it? Yeah, it's always decreasing on here. So it's always increasing, and then decreasing. So local max is at 0, -1, no local mean. And then we say our f double prime is 3x squared plus 4 all over x squared minus 4 cubed. So our Concavities test is just -2 and 2. This is positive. This is negative. It is positive. So concave up, concave down, concave up. So the graph is like that. Concave up. And then our asymptote, y equal to 1. I don't have not multiple colors, so it's hard to do like this. Okay. It's a very long graph.